Okay, in this tutorial, I'm going to show you how to conduct a statistical test, and you're going to use the result of this to report your actual mathematical result after you've told me whether you felt the hypothesis for discharge was accurate or not. The point of this test is that you can then say mathematically whether you're confident that discharge does actually increase as you move downstream. And you can tell me how confident you are. And that adds further support to the evidence you're providing regarding the accuracy of the discharge hypothesis. So the first thing you're going to want to do is open up the website, and there'll be a link to that in the conclusion step 5, and that will open up this here. And the other thing you're going to want to open up is the data spreadsheet that you used for your other graphs. Okay, now the first thing you're going to want to write, assuming you've just explained that you feel that the hypothesis is accurate and that it's proven, you're now going to want to write a sentence is, however, to prove or to see how confident I can be about whether this hypothesis is accurate, I am going to conduct a statistical test to see whether discharge is actually linked to the distance downstream. So does it increase as I move downstream? And what you then want to tell me is I'm going to use a Spearman rank test. So there's Spearman, the word Spearman, and this is called the Spearman rank test. Okay. So that's the first thing you're going to want to write. You're then going to want to get a number from this. So what you now need to do is, from the spreadsheet, the data entry spreadsheet that we used, you're going to want to copy sites 1 to 9. Copy that data. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just copying that, and I'm going to paste it in here. Now, you'll see my data is not coming properly. So I'm just going to go 1, enter 2, 3, 4, 5, 6, 7, 8, 9. Okay. Next thing I'm going to want to do is I'm going to want to get my results for each of those locations. Okay. So at site 1, what was the discharge? 0.01, 0.32. Okay. So if I just pull this over to one side, that will allow me to open up both tabs at the same time. There we go. Oh, this, I'll just pull this one across. Stretch it a little bit. I can now see the discharge. So I'm going to add 0.01. Enter. 0.32 was discharge at site 2. Enter. 0.30. Enter. 0.44. 0.48. 0.42. 0.17. 0.39. 0.4. Now, I'm just going to change these slightly, so you have to do this yourself. So I'm going to just change this one to 0.4. I'm going to change this one to 0.45. I'm going to change this one to 0.37. I'm just changing this so it forces you to actually have to conduct this yourself to get, so you're not just copying this off the video that I'm showing you. The next thing to do is, once you've got the 1 to 9 here on the X, that's the distance downstream, each site, and we've got our 9 discharge results lined up there, is we hit the calculate the R. And what this is going to do is give us a number. Okay. So the first thing we're now going to write is that my R value, my Spearman rank, returned a result of, and in this case, I've got 0.41. Okay. And you're going to want to write that down. The key thing now, though, is to tell me what that means. Now, of course, you're going to have a different result because I've changed the data slightly. So what does this result mean? So the next thing you're going to have to do is as follows. You're going to have to open up what's called a critical values table, which I will have left a link in the findings section. And when you open up your critical values table, like this one, and the link should take you to something that looks like this, you're going to have to look down what was our N? Now, we had 9 river sites, so our N is 9. And in order for our correlation or our relationship between distance downstream and discharge to be actually mathematically provable, our result would have to be greater than this number. And if it was, I could say that I was 95% confident. That's what that 0.05 means. I'm 95% confident as I move downstream, the discharge increase. Actually, if my number is bigger than this number, then I can go a little bit further. I can say that I'm 99% confident that there is a link between how far downstream I am and the river's discharge, that they're both increasing. And that comes from this. Now, our result is under both of these. So what do we say? How do we report this? We've reported our number. What we then have to say is that using a critical values table, my result is not significant to the 95% level. Okay, so if your number is smaller than this critical value here, you have to say it's not significant to the 95% level. Therefore, mathematically, there is not a relationship between distance downstream and the discharge of the river. Okay. Now, you can't just leave it at that. If that is your result, you've told me you've proved your hypothesis based on the line graph, but you're now telling me mathematically there isn't. So what you have to say is that, but what is clear from my graph, figure, whatever you've called it, is that there is an overall increase. The problem is that the discharge varies greatly as you move downstream because of lots of other factors. For example, the urban environment, the type of rock over which it flows, the farmer's field, the farmer extracting water. And that variability is why mathematically it is unproven that there is a relationship downstream. Okay, so at that stage, you'll then jump back into the rest of your conclusion, just rounding up saying that, yes, I've proven my hypothesis, however, mathematically, I cannot prove it because of the variability in things changing discharge. If your result happened to be bigger than this 0.7, what you could then say is that actually my result is bigger than the critical value for 95%. And actually, if it's bigger than this, you'll say it's bigger than 99%, which means I have mathematically proved there is a relationship between distance downstream and discharge, which adds further strength to my original conclusion that the hypothesis proved correct. Okay, so there you go. If you understand this, please write up the result you get from the calculator, pop it in after you've drawn your kind of conclusion on your hypothesis based on the graph that you were using, and then finish off that and move on to your second research question.